In the last presentation, I introduced binary number system to you. From this lecture, we will start conversion part of our number system. The first conversion that we have to study is decimal to binary conversion. We have two methods to convert a decimal number to binary, and we will start with first method. Let's say the decimal number is 13 and we want binary equivalent of 13. If you remember the last presentation, I introduced positional weights for binary number system. Let's say the number is B0, B1, B2, B3. These are the bits of binary number. Then the weight of this position, the 0th position, is 2 raised to power 0. Weight of this position is 2 raised to power 1. Weight of this position is 2 raised to power 2. And weight of this position is 2 raised to power 3. Right? And 2 raised to power 0 is equal to 1. 2 raised to power 1 is equal to 2. 2 raised to power 2 is equal to 4. And 2 raised to power 3 is equal to 8. We can also have 2 raised to power 4 equal to 16, but we do not require 2 raised to power 4 because the number in decimal is 13. We want to convert 13 and 16 is greater than 13. So we do not require 2 raised to power 4. And out of 1, 2, 4, 8, the number closest to 13 is 8. So we can write 13 equals to 8 plus 5, right? 5 is not there. We are allowed to select from 1, 2, 4 and 8. We have selected 8. Now we have to select number closest to 5 and the number is 4. So 5 we can write 4 plus 1 and fortunately 1 is there. So 13 we have to write 8 plus 4 plus 1. And now we have to find out the values for B0, B1, B2 and B3. And it's very simple. You can clearly see 1 is 2 raised to power 0 and it is included. So B0 is going to be 1. 2 raised to power 1, which is 2, is not there. So B1 is going to be 0. 2 raised to power 2, 4 is there. So B2 is going to be 1. And 2 raised to power 3, 8 is also there. So B3 is also 1. So the binary number is 1101. The binary equivalent of 13 is 1101. This is the first method to find out the binary equivalent of a decimal number. But this method is not preferred. We will have another method, another simple method to find out binary equivalent of a decimal number. In this method, we have to divide the number by 2. To convert decimal number to any other base, r, in this case, r is equal to 2, we have to divide the integer part by r and multiply fractional part by r. First, we will see example in which there is no fractional part. Then in next example, we will solve one problem in which there is fractional part. So for first example of method number 2, we don't have the fractional part in the decimal number. And let's consider the same scenario. The number is 13. Okay. Now we have to divide 13 by 2. So we will do this quickly. (13) and 2. 13 is dividend and 2 is divisor. When we divide 13 by 2, we have 6 and the remainder is 1. Now the 6 is quotient and 1 is remainder. 6 is quotient and 1 is remainder. We again have to divide the quotient by 2 and the result is 3 with remainder equal to 0. And we will continue the same process. We will divide 3 by 2. Quotient is 1 and remainder is also 1. We will again divide 1 by 2. Quotient is 0 and remainder is 1. We have to repeat the process until we have quotient equal to 0. When we have quotient equal to 0, we will stop because when you try to divide 0 by 2, you will have quotient again equal to 0 with remainder equal to 0. And the process will repeat and every time you will get remainder equal to 0. The remainder will give us the binary number. But there is one twist. We have to start looking from bottom. 1, 1, 0, 1. As we have already seen, the binary equivalent of 13, the answer is 1101. So don't consider this one as MSB. If you consider this as MSB, the result will be 1011, which is not true. So this one right over here is the MSB, the most significant bit, and this one, the first one, is LSB, the least significant bit, and MSB is the leftmost bit, so we have 1 here, and LSB is the rightmost bit, so this one comes here. So this is the binary equivalent of number 13. We have to start looking from bottom and we have to go up like this. So this is the second method and result is obviously 1101. This is most preferred method to convert decimal number to binary. Now we will consider another example in which we have fractional part also. The number is 25.625. This is in decimal, and we want binary equivalent of this number. So what we have to do? We have to divide the integer part by 2, and we have to multiply the fractional part by r. And in this case, the integer part is 25. This is integer part, and 0.625 is the fractional part. So we will do this quickly because you already know the concept. We will have 12 as the quotient, 1 as the remainder, 6, 0, 3, 0, 1, 1, and finally we have 0, 1. So the binary equivalent for 25 is 1, 1, 0, 0, 1, because we have to look from bottom to up. So this one is MSB and this one is LSB. 1, 1, 0, 0, 1. Now we have to solve for fractional part. The fractional part is 0.625, and we have to multiply 0.625 by 2, and this will give us 1.25. Now listen carefully what we have to do. We have to consider this integer part, 1.25 we have to consider, and we have to take it out. And once we have 1 taken out, we have 0.25 left. And we again multiply 0.25 by 2, and the result is 0.50. And now we have a 0. So we are left with 0.50. 0.50 multiplied by 2, and this will give us 1.00. We will take this 1, and finally when 0.00 is multiplied by 2, 0.00 is multiplied by 2, we have result as 0.00. And this 0 you can take out, of course, and when you repeat the process, you will have bunch of zeros. And when we have to consider these ones and zeros in the result, we do not go from bottom to top, but we go from top to bottom. We will go from top to bottom. We will consider this 1, then this 0, then this 1. So we have 1, 0, 1, 0. You can consider this 0 and so many zeros after it, because it will not change the result. In the same way, when you consider this 0 and all the other zeros following it, you will have more zeros before this 1, and these zeros will not change the result. So we do not include them in the answer. Our answer is 11001.101. This is the binary equivalent for number 25.625. So there are two important things that you must know. In case of integer part, you have to go from bottom to top, and in case of fractional part, you have to go from top to bottom. Here you have to divide it by 2, and in this case you have to multiply it by 2. Now we will move to homework problem. There are two homework problems. First one is 67 in decimal, and you have to convert it to binary. The second problem is 129.75 in decimal, and you have to convert it to binary. Once you have your answer, post it in comment section, and we can definitely fill the answer here, 11001.101. This is all for this presentation. If you have any doubt, go ahead and ask. See you in the next one.